Hello, today I'm going to talk to you about the Hertzsprung-Russell diagram. We will call it HR diagram for short. It looks busy, but once you understand it, it won't be that bad. It's a diagram that helps us understand a little bit more about stars, and it is plotted, it's a scatter plot based on the star's brightness and the star's temperature. So here we'll use the star as an example here. Let's look at Vega all the way over here. Vega has a brightness of looks like maybe a 1, right? And the temperature, if you go follow down, you'll see the temperature is about, I don't know, 15,000 degrees. So it gives us a lot more than just brightness and temperature, but that's how we look at this diagram. On the left side of the diagram, stars that are on the left side are very, very hot. They can go up to 50,000 degrees on the left side. Stars that are on the right side are not as hot. They're still hot. We're talking 3,000 degrees. So the diagram goes hotter as you move to the left of it. So on the left, like we said, the stars are hotter. And then when you move to the right, they are not as hot. At the top of the diagram, we have very bright stars. -10. The lower the number, the brighter the star. -10 is very bright. Look at Deneb up here in the North Star. They are very bright stars with negative numbers. When you get to the bottom of the diagram, these stars are not as bright. These numbers are higher, but they're not as bright. So the lower the number is, the brighter the star. Okay, stars at the top left to the bottom right are in your main sequence. So this area here, these stars are in their main sequence stage of their life. Okay. They're here for about 10 million to 10 billion years. Our sun is in its main sequence stage. 90% of the stars in the universe are in the main sequence stage of its life. So these stars plotted here are all in the main sequence stage. Okay. For the most part, 90% of the time, if we're looking at the main sequence, the brighter the star is, the hotter it's going to be. There are some exceptions. We have our red giants here. These guys are very bright, but their temperatures are lower. And the reason they're so bright is because they're so big. Then we have our white dwarfs down here. They are pretty hot, but they're not that bright because they're so small. But most of the time, the brighter the star is, the hotter it will be. Okay, so here, like I said, the white dwarfs are here. They're not very bright, but they are very hot. And the red giants, like I said, also, they are very bright, but they're not very hot because they're so big. Okay. The spectral class is found along the top here. Example, Deneb. If we find Deneb, here it is. The spectral class is A, and it is a white star. We're also looking, you can see the colors of each star. Like our sun is yellow. Okay. They're not plotted on the diagram according to their location. This is important to understand. They're plotted based on their brightness and their temperature, not on their location. So just because the sun is here and Alpha Centauri is here, does not mean that these are this close in the universe. It just means that they have similar characteristics. Our sun has a brightness of 5, and so does Alpha Centauri. Our sun's temperature is about 6,000, a little more, and so is Alpha Centauri. Our sun is yellow, so is Alpha Centauri. Our sun is a main sequence, so is Alpha Centauri, and you get it. So they are not plotted based on their location. You cannot tell location, you cannot tell distance, but there are a lot of things we can tell by looking at the diagram, such as color, brightness, temperature, stage of their life. So when we looked at this diagram in the beginning, it was very confusing, but once we went through it, you're able to tell a lot more after going through it. Good luck, and we'll speak again soon.